factorized version. So now we have successfully expressed 12x plus 8 as a product of 4 and 3x plus 2. If you use 4 to multiply the values in this bracket, the expression in the bracket, you're going to get back 12x plus 8. If you don't understand it, ask me in my comment section or send me the question in my WhatsApp. You know my WhatsApp number is there on the flyer. It is plus 23470. It is plus 23470706845. So this is my WhatsApp number. So if there's any part of this that you don't understand, send me the question in WhatsApp or you write it in the comment section in YouTube. So I'm going to take you back. This is example 4, right? But I'm going to quickly take you back to the previous example we did, example 1, example 2, and example 3. So these are the expressions for example 1. This is the expression for example 2. This is the expression for example 3. I just want to quickly correct an omission that I made. Now, the factors of 8 and 12, I omitted 8 and 12. So 8 and 12 are also factors of 8 and 12 because 8 can divide 8 without remainder, 12 can divide 12 without remainder. So the same thing applies to the second expression in example 2 and the expression in example 3. 15 is a factor of 15. 20 is a factor of 20. 12 is a factor of 12. 18 is also a factor of 18. So I omitted that in the examples. So I just want you to take note of that. Example 4, we are asked to factorize 6x plus 9x squared. And this time around, we're going to use a different approach. The subtopic says factorizing expression with variables. And in the previous example that we did not factorize a variable. We only factorize the numbers. But in this case, we're going to include factorizing the variables in the algebraic expression. So the common factor may contain a variable. Let me take you back to our previous example. Let me see. 15x plus 20. This is example 2. This was the expression in example 2. Now you can see that though the expression contains two terms, 15x and 20, but the terms are not the same. 15x is an algebraic expression and 20 is a constant. So in that case, the factor cannot contain the variable x because 20 does not have a variable. So I want you to take note of that. So that is why our highest common factor for 15x plus 20 was 5. So we now express this as 5 multiplied by 3x plus 4. Now you can see that this factor here, the highest common factor, does not contain x. Why? Because x is only present in one term in the expression, 15x. It's not present in 20. So we cannot include x here. If we include x here, the expression is going to be wrong because this will now become 5x multiplied by 3x. This will give us 15x squared plus 20x, which is different from the original expression. Okay? But in this example, example 4, look at it closely. You see that the two terms contain the variable x. X is present here, x is also present here. This means that the common factor will also contain x. Take note of that. The common factor will contain x. So now let's use the approach that we used previously in the previous example. So I'm going to look for the common factor of, or rather the highest common factor of 6x and 9x. So what am I looking for the highest common factor? Why don't I just look for the common factor? The reason why I'm looking for the highest common factor is because I want my expression to be in its simplest form. That's why I'm looking for the highest common factor. I explained that previously. Okay, so now in this instance, we have 6x plus 9x squared. So we're going to look for the highest common factor of 6x and 9x squared. So to do that, we are going to express 6x, or we're going to write out the factors of 6x. And the factors of 6x are 2x and 3x. While the factors of 9x squared, 6x, the factors of 6x are 6x, 3x, and 6x. I did the same omission again. So I need to also include 6x as well. So we have 2x, 3x, and 6x. The highest common factor, the factors of 9x squared are 3x. 3x is a factor of 9x squared. 3x squared is a factor of 9x squared. Then 9x squared is also a factor of 9x squared. 9x squared can divide 9x squared without remainder. 3x squared can also divide 9x squared. 3x squared can divide 9x squared, the result is 3. 3x can divide 9x squared, the result is 3x. Now, so the next thing I'm going to do, I will look for the highest common factor. So the number that is present in the factors of 6x and also present in factors of 9x squared. And that number is 3x. So 3x is the highest common factor. So what are we going to do? What is going to be the next step? You know that when we are factorizing, we have to express the original algebraic expression. We have to express it as a product of two or more factors. So we have been able to derive one factor, and that factor is 3x, which is the highest common factor of 6 and 9x squared. So the next thing we're going to do, we're going to find the other factor of 6x plus 9x squared. So to do that, we're going to divide 6x plus 9x squared with 3x, which is this value here. So 3x into here is going to give us 2x. Sorry, it's going to give us 2. And 3x into 9x squared is going to give us 3x. So the product of these two values is going to be the factorized version of 6x plus 9x squared. So this can be expressed as 6x plus 9x squared is equal to 3x multiplied by 2 plus 3x. Can you see it? 3x multiplied by 2 plus 3x. Now, if you expand this, if you remove the bracket, this is going to give us 6x plus 9x squared. This is another algebraic expression. In the expression contains variables. So when you see something like this and you're asked to factorize it, it means that the highest common factor that you're going to use must also contain the variable a. If you can take your mind back to, I think that was in lesson 1. In lesson 1, we said that any algebraic expression that has 2 terms is referred to as a binomial. So this is a binomial. All right. Now, to factorize this binomial, 8a squared plus 12a, we have to look for the factors of 8a squared and the factors of 12a. So what are the factors of 8a squared? Factors of 8a squared are 2a. 2a is a factor. 4a is a factor. 4a squared is a factor. Even 2a squared is also a factor. 2a squared is a factor. and 8a squared is also a factor. I'm not sure I did that in the previous example. So 2a is a factor, 2a squared is a factor, 4a is a factor, 4a squared is a factor, 8a squared is also a factor. Then 12a, the factors of 12a are 2a is a factor, 3a is a factor, 4a is also a factor. Once again, the reason why they are factors is because if you use them to divide the original number, it will divide the original number without any remainder. So these are the factors. Now the next thing we do, we now consider both factors and look for the highest common factor. So in this case, the highest common factor is 4a. So 4a is the highest common factor. So the next thing I'm going to do, now I know that my HCF is equal to 4a. So I'm going to use 4a to divide 8a squared plus 12. 8a squared plus 12a all over 4a. 4a divided 4a squared is going to give me 2a, because 2a multiplied by 4a squared is 8a squared. 4a squared divided by 12a is going to give me 3, because 3 multiplied by 4a is 12a. So now I'm going to multiply these two values. Therefore, 8a squared plus 12a is equal to 4a multiplied by 2a plus 3. So this is the factorized version of 8a squared plus 12a. Factorization of three-term expression. Look at this example, example 6. This is a different algebraic expression. This is a three-term algebraic expression, and this type of algebraic expression is referred to as a trinomial because it contains three terms. All right, so we have 6x plus 9y plus 12. So now the question says that we should factorize 6x plus 9y plus 12. Now we cannot apply what we did previously in this expression because number one, the variables are different. And the term 12 does not carry any variable. So 12 is a constant. So we cannot apply the factorization method we did previously where we looked for the highest common factor that contains a variable. So we're using a different method here this time. So, but first of all, what do we do when we have this scenario where you're asked to factorize 6x plus 9y plus 12? What do you do? So, just like we did in the previous examples, what we need to do is to look for the factors of each of these terms. So we're going to take 6, we're going to take 9, we're going to take 12. So we look for the factors of these three numbers. The factors of 6 are 2, 3, and 6. Factors of 9 are 3 and 9. Factors of 12 are 2, 3, and 4. The next thing, and 12. The next thing, we're going to compare the factors of the three numbers and look for the highest common factor. So, and the highest common factor here is 3. So 3 is the highest common factor. So our HCF is equal to 3. The next thing we're going to do, we're going to use 3 to divide this expression. So 6x plus 9y plus 12 all over 3. So 3 into 6x is 2x. 3 into 9y is 3y. And 3 into 12 is 4. Therefore, we can express 6x plus 9y plus 12 as 3 multiplied by 2x plus 3y plus 4. 3 multiplied by this is 6x 3 multiplied by this is 9y, 3 multiplied by this is 12. So this is the factorized version. So sometimes there is no simple factor that is common to all the terms. Now you know that we have done 6 examples, and in those 6 examples, we have been using one strategy. We have been looking for a common factor in the terms. And there are situations where it is impossible for you to find a common factor. So in that situation, the method you are going to use is factorization by grouping. So you group the terms inside the expression that have common factors. So that is the method we use in that situation where you cannot find a common factor for all the terms in the expression. You group the terms and then you look for a common factor for each group. So now consider this expression. This is ax plus ay plus bx plus by. Now we can see that we cannot find a common factor for each of the terms in this expression, right? So in this situation, what do? We use the grouping method. So this is what I am going to do. Because A is present here and A is present here, I'm going to group these two terms. Because B is present here and B is present here, I'm also going to group these two terms. Then after that, what am I going to do? I will look for the factors of AX and AY. The factors of AX and AY is A. And the factors of BX and BY is B. Now you can see now that we have a common X plus Y. So because X plus Y is common, we're going to take 1x plus Y. So this expression can now be written as A plus B x plus y. So this is a factorized version of ax plus ay plus bx plus by that does not have a common factor. Example number 7. Factorize 3x plus 3y plus 2x plus 2y. Here again, you can see that we cannot find a common factor for this polynomial. This is a polynomial because it has many terms. So an algebraic expression that has many terms is referred to as a polynomial. So the terms do not have a common factor. In this case, when we are asked to factorize this type of expression, we use the grouping method. So we group terms that have a common factor. So if you look through the expression, you will discover that 3x plus 3y has a common factor, and the common factor is 3. Therefore, this can be expressed as 3 multiplied by x plus y. Or what you do, first of all, you group the terms that have a common factor. So that is where the term grouping came from. You group the terms that have a common factor. And then after grouping the terms, you now factorize. So now we're going to factorize 3x plus 3y. 3x plus 3y, the common factor of 3x plus 3y is 3. Therefore, this can be written as 3 multiplied by x plus y. How do you check if your factorized version of an expression is correct? To find out if the expression is correct, if the factorized version is correct, what you do, you expand the resulting expression. You expand it. You open up the bracket. Now, if we open up this bracket, this expression is going to be 3x plus 3y. So we're going to get back the original expression, right? So if you're able to get back the original expression, then your answer is correct. But if you cannot get back the original expression, then there's an error that you need to correct. So 3x plus y is in order because if we expand it, it will give us back this Therefore, the common factor of 3x plus 3y is 3. The common factor of 2x plus 2y is 2. Okay? And now we have factorized the expression. So the next thing we are going to do, we're going to collect like terms. X plus y are common. Therefore, we're going to rewrite this expression as, okay, so we're going to rewrite this expression as 3 plus 2 multiplied by x plus y. So this is a factorized version. So this is a factorized version. So wait, factorize ax plus ay plus 3x plus 3y. Now once again, look at this example, example 8. We're asked to factorize ax plus ay plus 3x plus 3y. Now we can see again that there is no common factor here. So what do? We apply the grouping method again. So we group terms that have a common factor. Because a is present here and a is present here, I'm going to group these two terms. Because 3 is present here and 3 is present here, I'll group these two terms. And the next thing I'm going to do, I'm going to factorize each of the terms. So the factors of ax and ay is a. And if I take away a, I'm going to be left with x plus y. The factors of 3x and 3y is 3. If I take away 3, I'm going to be left with x plus y. Right? So the next thing I'm going to do, I'm going to rewrite this expression as a plus 3 multiplied by x plus y. So this is the factorized version of our original expression. A plus 3 multiplied by x plus y. Negative common factors. There are certain algebraic expressions where you come across negative common factors. If you're in such situation, what do? In example number 9, we're asked to factorize minus 6x minus 12. So once again, let's look for the factors of minus 6 and the factors of minus 12. So what are the factors of minus 6? We look for values that can divide minus 6 without remainder. So we have minus 2 is a factor that can divide 6 without remainder. Minus 3 is also a factor that can divide 6 without remainder. And then minus 6 is a factor that can divide 6 without remainder. Remember, carry the negative sign along. What are the factors of 12? The factors of 12, minus 12, sorry. The factors of minus 12 are minus 2 without remainder. Minus 2 can divide 12 without remainder. Minus 12 without remainder. Minus 3 can divide minus 12 without remainder. Minus 6 can divide minus 12 without remainder. And then minus 12 can also divide minus 12 without remainder. So after doing this, after writing out the common factors, or rather, after writing out the factors of the numbers, you now compare the factors and then find the highest common factor. So in this scenario, the highest common factor is minus 3. Sorry, the highest common factor is minus 6. So 6 is common here, 6 is common here. So to factorize this expression will now become minus 6 multiplied by x minus x plus 2. And the reason why I put plus 2 here is because if minus 6 multiply plus 2, the result is going to be minus 12. But if I put minus here, if the sign there is minus, minus 6 minus 12 is going to give us plus 12, which is not correct. So to get back minus 12, we are going to put a positive sign here. So that minus 6 multiplied by the positives, minus 6 multiplied by plus 2 is going to give us minus 12. So this is the factorized version, minus 6x plus 2. Or we can rewrite this expression as 6 multiplied by minus x minus 2. Right? 6 multiplied by minus x minus 2. So this is another answer, another factorized form. 6 multiplied by minus x will give us minus 6x. And 6 multiplied by minus 2 will give us minus 12. So which of them is the answer? Both of them is correct. When you get to this part of the video, pause the video and answer these questions. And the questions are made up of two parts. The first part contains mixed questions. There's a part of it where you have to look for the highest common factor of the algebraic expression. There's a part of it where you have to look for the highest common factor with the variable or that contains variable for the algebraic expression. Then the second part of the questions, you are going to apply the method of grouping to factorize the algebraic expressions. So when you are done with the assignment, send your answers to the comment section in YouTube or send them to my WhatsApp number. So I'm going to write my WhatsApp number again on the board. The WhatsApp number is +234 70700 6845. So this is my WhatsApp number. So send your answers to this assignment to the WhatsApp number. Or you post it in the comment section of the YouTube video. You post it in the comment section of this. Okay, and after watching the video, kindly like the video, share the video, and subscribe to my YouTube channel. I'll see you in lesson 4.